Hey everyone, in this video we're going to be talking about the derivative. Now we already know that limits is one of the foundational concepts in calculus. Well, the first major thing that we need limits for is the derivative. So we have already talked about the slope of a tangent line. We've talked about the instantaneous rate of change. And if you go even further, we can also talk about velocity at a specific point. Well, the underlying foundation for all of those is what we call the derivative. So this is something that we just use so frequently, this idea of slope of a tangent line. We give it a special name, and that's the derivative. So what I'd like to do is do a specific example where we find the derivative at a specific point. So here's my example. But just to start off with, let's remind ourselves of what the derivative is. So the derivative, or the slope of the tangent line, or the instantaneous rate of change, they all represent the same thing. So f prime of c, this is going to be equal to the limit as x approaches c of f of x minus f of c all over x minus c. So in this notation, f prime of c, so this is prime notation, this represents our derivative. So if I look at my example, I'm given this function, and I want to find the derivative at x equals 2. In other words, I want to find f prime of 2. So if I see that notation, f prime of 2, I know that this is asking me to find the derivative at 2. So the first thing I'm going to do, because I know I want to plug everything into my derivative, I am going to find f of c right away. So I want to find f of 2 just so I have that easily available to plug into my formula. So f of 2, 2 times 2 squared, minus 3 times 2, and minus 2. So if we evaluate this, let's see what we get. 2 times 4 minus 6 minus 2. We get 8 minus 8, so f of 2 is equal to 0. All right, just so we have that, so we can plug it in. So to find our derivative at 2, we have the limit, and as x approaches c, which in this case is 2, f of x is our original function, so 2x squared minus 3x minus 2. F of c, we just found that was 0. And then we want to divide this by x minus c, which is x minus 2. Okay, subtracting 0, we don't need that minus 0, so let's clean this up. So we have 2x squared minus 3x minus 2 all over x minus 2. And this is the limit we want to evaluate. Evaluating this limit will give me my derivative. So if I notice, I can't just plug in 2. That would give me an indeterminate form. So let's try and simplify. And let's start by factoring the numerator. In factoring the numerator, we end up with x minus 2. And we are left with 2x plus 1. And this is still over x minus 2. And that works out because now I have this common factor that will simplify. And what I'm left with is the limit as x approaches 2 of just 2x plus 1. And now in this simplified form, to evaluate this limit, we can just substitute in 2. So 2 times 2 plus 1, we end up with 5. So our final answer then, the derivative at 2 is equal to 5. And in other words, the derivative, the slope of the tangent line at 2, the slope is 5. The instantaneous rate of change at 2 is 5. The velocity at 2 is 5. All of those things represent the derivative.